I'm Carly Miller from the University of Illinois, and today we're talking about fish. All right, so to get a little taxonomical terminology going here, we're in the phylum Chordata and the subphylum Vertebrata. All right, so most people probably have an idea of what that is, but we have a few technical definitions that I'd like to go through real quick here. So the physical traits that define a fish, as opposed to a mammal or a tetrapod or an amphibian, something like that, is first of all the presence of gills. So gills are kind of openings on the lateral sides of the organism that allow for the kind of the diffusion of oxygen and the kind of the capturing of oxygen for the usage of that organism. Next, they have vertebrae that are spool-shaped, actually. So we have a nice, huge specimen here. And so what we're looking at here is kind of this overall circular shape. And if I can turn it to the side even, you can see that it kind of pinches in on the sides a little bit. And so that's where we're getting our spool shape. And I'll turn it another direction so you can see here the spool shape of that. And so what I want to show you here, just point out, so you're saying, well, overall, that's not spool shaped. Well, what this is actually a neural spine. So the opening here coming through the middle is kind of a passageway for the spinal cord, really, or nerves running down the kind of the vertebral column. That's what this is for. And so how that differs from land animals is that we have this spool shape, and so if you can think of them kind of connecting together, they're almost just bumping together as opposed to being really interlocking in their skeletal structure there. So that's something that's unique to fish. And what it does is it allows the fish to be more flexible, really, and so it can use its muscles a little bit better to swim through the water column. So we have this spool-shaped vertebrae that's specific to fish. Additionally, all fish are aquatic. That seems logical if you've ever seen a fish, all right? So all fish are going to be aquatic organisms. We have no amphibians here transitioning from land to water or anything like that. So they're all going to be aquatic organisms. All right. Additionally, we want to introduce to you the idea of how the shape of the organism can translate to kind of its life strategy or the function of its overall body. So we're going to talk about the fish triangle. Sounds exciting. It's pretty exciting. And so what this is kind of a diagram that describes how you can observe the fish and then sort of place it on this diagram and then identify what it does. So we'll kind of dive in here. So we have three groups of fish. We have accelerators, cruisers, and maneuverers. So I'll kind of walk through each of these and let you know which features to look for when trying to identify what these guys do. So accelerators, if you can imagine, a fish kind of lurking in the murk in a pond or a river, and they have to kind of dart out and maybe catch their prey or maybe escape a predator. These are called accelerators, and how you can identify them is the back of their tail is actually kind of thick compared to the rest of their body. So they're almost like a tube or a column shape. And so there's no real indentation where that tail is, but it's just kind of a really thick muscular tail, and it allows them to do a really quick whip motion, and they can accelerate through the water really quickly. So we're kind of looking for almost like a shapeless fish, kind of like a column shape for that fish to identify as an accelerator. The cruisers, these guys are kind of gorgeous, I think. These are really kind of hydrodynamically shaped fish. So they're really sleek. They kind of have that fusiform body shape. They can cut through the water really easy. And what cruisers are thought to be able to do is just go for miles underwater in our vast oceans on Earth here, and with very little expenditure of energy. So these are our cruisers. And you might think of a shark, actually. They're a great example of a cruiser. They have those stiff pectoral fins that just slice through the water. Their bodies are really sleek, and just a little flick of the tail every now and then just sends them right through the water. So these are our cruisers. The last group of fish are the maneuverers. These guys are wildly varied in their shapes of their bodies, but what they primarily do is they use their pectoral fins to kind of just pivot, turn on a dime, if you will, just pivot in the water, and they can just kind of maneuver into tight spaces. They're not really built for speed, unfortunately, but they definitely have a great function, and that's just pivoting around in the water. They can kind of weave their way into a protective area, perhaps. So you're looking for these really just kind of nice pectoral fins that they can use to maneuver around. All right, so within the group fish, we're going to dial into the superclass Agnatha. So Gnath, G-N-A-T-H, that refers to the jaw, and anytime you put an or a before that in kind of the Latin, your Greek and Latin roots there, that means the lack thereof, more or less. So we have Agnatha here. And these are your jawless fish. So jawless fish arose in the Ordovician, and they still persist today in the recent. There's between 4 and 7 classes depending on taxonomy. That gets a little dicey with your taxonomical hierarchies there, but there's between 4 and 7 classes of agnathans. So these are filter feeders primarily, or detrital feeders. And so if you think about it, if you don't have a really great functioning jaw, it's going to be difficult to chew, for example. And so they're usually kind of scooping up some of the detritus or the sediment on the bottom of the ocean and kind of filtering it out and absorbing the nutrients that way. Or they're kind of swimming through the water column and maybe picking up some plankton or something like that, the nutrients from the water column as they swim. There are some, I think I've seen, on a great program where they're actually allowed to attach, themselves to maybe a whale carcass or something, and they can almost tie themselves in a knot and pull themselves off. It's kind of amazing. And they actually do get a chunk of meat there, which is amazing. They don't even have a jaw, but they're allowed to get those types of nutrients. So I don't think I'd want to work that hard to eat my dinner, that's for sure. But they've adapted very well there.